Here's an interesting problem. We want to find the floor of x squared plus the floor of y squared equal to 1. Well, everyone knows that x squared plus y squared equals 1. That's the unit circle. That is, the radius is 1 because 1 is r squared and r is the radius. So the area of the unit circle is pi times r squared, or pi. But I want to know what the area is for this up here, for this equation. Now, for those of you who don't know the floor function, the floor of a number is the largest, let me make this 3.2. It's the largest integer it obtains, namely 3. So basically, a floor function only gives integer solutions. If you are at 1.7, you've already reached 1. It didn't quite reach 2 yet. So the floor of 1.7 would be 1. If you're at 3.5, you didn't reach 4 yet, but you sure reached 3. The floor of 3.5 would be 3. Of course, the floor of 4 would be 4 because we reached 4 yet. We reached 4. What about negative 2.3? A lot of people may say, oh, that's negative 2. But the answer is it is negative 3. Because just like with positive numbers, you're coming from the right. Let's look at this one. We reached negative 1, we reached 0, we reached 1. We didn't reach 2. It's the largest number that we reached. That is, it's the integer to the left, the first integer to the left, unless you're at an integer. 1, 2, 3, 3.5. We reached 3. We didn't reach 4 yet. It's the first integer to the left, unless you're at an integer. Then the floor of that integer is itself, that integer. So the integer of negative 2.3, the first integer to the left is negative 3. Of course, the floor of negative 1, we won't go one integer to the left, or the first integer to the left. If you're an integer already, the floor of that number is itself. So this is what floor means. Now, x squared is greater than or equal to 0. It's never negative. Y squared is greater or equal to 0. So the most x squared can be is 1. Well, let's just look at this equation for a moment. Since this is positive, the most it can be is 1. Can't be 2. The most this can be is 1. It can't be 2, because 2, if this is 2, then, this is 0 or more. And if you add 2, it'll be greater than 1. In fact, it'll be greater than 2. Since x squared is at least 0, it's at least 0. It obtains 0. This is going to be at least 0. This is going to be at least 0. If you add two numbers and they're at least 0, You want the sum to be 1. None of them can be more than 1. And this is always an integer. An integer greater than or equal to 0. This is an integer greater than or equal to 0. So the left one, the floor of x squared, can either be 0 or 1 or 2 or 3 or 4 or 5. But then for most of those numbers, the sum couldn't be 1. Either the floor of x squared is going to be 1 and the floor of y squared will be 0. That way, 1 plus 0 gives us the 1. Or the floor of x squared is 0 and the floor of y squared is 1. There's only two cases, case 1 and case 2. Let's look at case 1. The floor of x squared is 1. Now forget about x squared for a moment. What kind of numbers can you put in there so it's 1? You have 0, 1, and 2. Well, the floor of 1 is 1, and anything up to 2, the first, but not including 2, the integer to the left will be 1. So this means that x squared is in between 1 and 2. It can equal 1. So let me write that above. Whatever this is, I don't care if it's x squared or x plus 7. It must be in between 1 and 2, equal to 1, not equal to 2, for the floor to be 1. This means, so let's talk about just quadrant 1 where x and y are both positive. This means that x is in between 1 and the square root of 2. It can be 1. I took the square root of all three sides. That's what happens for x, or x squared. Now in case 1, means the floor of y squared is 0. Well, here's a nice number line. Here's -1, here's 0, here's 1. The floor is always to the left. Well, first, let's rule out the case where it's not to the left. The floor is 0 is 0. If you go up to 1, but not including 1, the integer to the left is 0. That means that y squared must be in between 0 and 1. It could be 0, but it can't be 1. Why can't y squared be 1? Because the floor of 1 is 1. It's not 0 like we're saying we want it to be. Okay, so this means that y must be in between 0 and 1. Now, if I were to graph this, now since we're only doing the first quadrant, let me have a little bit bigger of a graph. So y goes between 0 and 1. And x goes between 1 and square root of 2. That means I'm in here. All these x's are between 1 and square root of 2, and all the y's are between 1 and 0 and 1. All the y's are between 0 and 1. Okay, that was case number 1. Let us consider case number 2. I put as much of it here until I need more space. Case number 2. This is when the floor of x squared is 0. But it's symmetrical. That's this answer. That means that 0 y is between 0 and 1. Also, it means that the floor of y squared is 1. Well, that means that the floor of x squared, oh, x is between 0 and 1. Excuse me. And the floor of y squared being 1, that means that y is in between 1 and square root of 2. The x is between 0 and 1, and y is in between 1 and square root of 2. That means we're up here. But you know what? Both of these same rectangles, non-overlapping rectangles, they appear in all 4 quadrants. So let's just find the area of these 2 triangles. Well, this base goes from 0 to 1, so it's 1. And the height goes between square root of 2 and 1. So the height is square root of 2 minus 1. So let me erase this down here. And the area is of the black one is square root of 2 minus 1. The area of the red one is the same, because this height goes from 0 to 1, which is 1, and the base goes from 1 to square root of 2, so its base is square root of 2 minus 1. You add, so it's the same area that I wrote down. You add the same areas, you get 2 times it. Now this is for quadrant 1. Now the total area is going to be exactly what we just got times 4. It's going to be 8 times the square root of 2 minus 1. And that answer is approximately 3.314. This is a really interesting problem. You can think of area of, you can now compute area with some floor functions, which is pretty cool. I think this was the coolest. If you like math like this, continue watching my channel. Tell your friends and teachers about it. Please leave a comment below. Subscribe to my channel. And good luck with your math. Have a great day.